Okay, so let's continue with solubility equilibria. Okay, so last time we were able to talk about acid-base. So, na-cover na natin yung kailangan i-cover sa topic na to. So, we were able to know how to write the K for acids and bases. For acids, that's called Ka. And then for bases, that's called Kb. No? Okay. And the relationship of Ka and Kb, when you multiply them, that's equal to the ion product of water, Kw. Okay. Ayun. So, also if you have a mixture of conjugate acid-base pairs, then you have a buffer solution. And they are governed by the Henderson-Hasselbalch equation. Okay. So, ngayon naman, punta na tayo sa last application of the equilibrium system. This is called the solubility equilibria. So, look at the examples I showed here. Ayan. So, how can we describe solubility equilibria? By just looking at the following examples. So, we have silver chloride, which we know is a precipitate. Magnesium fluoride, also a precipitate. Silver carbonate, also a precipitate. And we have calcium phosphate, another precipitate. So basically, when we say solubility equilibria, this describes the ionization of our precipitates. So this equation shows us how our precipitates dissociate into their respective ions. Okay. So if we write the KSP, if we write the equilibrium constant, in this case, that's called the KSP, the equilibrium solubility product. So yun yung meaning ng SP. Okay. So yan, that is a solubility product, KSP. So if we write the KSP, what we can notice is that only the amounts of your products are written in the K. Why? Because your reactants are all solids. So, kapag KSP ang usapan natin, lahat ng ions sa product, yun ang ilalagay mo. And also, take note that you should express their correct dissociation. So, you should still follow their original charges and their stoichiometry according to their formula. Okay, so basically, solubility equilibria, this describes the dissociation of ions of precipitate. Baka ito isipin nyo kasi na precipitate yan, sir, di ba? Bakit yan nagde-dissociate, Ang correct term kasi for precipitate is sparingly soluble solids, Okay, so pag sinabing sparingly soluble, they are still soluble but to a very, very small extent, So soluble sila pero onti lang masyado. Kaya it seems like they are solids, Okay. And this is the KSP table of different salts that we will need, So please save this table. Kailangan natin lahat ng KSP values na yan when we solve for the equilibrium amounts of your ions. Okay. Another term that we use to describe the solubility equilibria, other than the KSP, is the molar solubility. The molar solubility refers to the moles of your solute dissolved in 1 liter of saturated solution. So basically, this corresponds to the equilibrium concentration of your ions after calculating for them. So, diba, you have the K expression, and then you express them in terms of X, diba? Okay? So, whatever the value of X is, kung ano man yung yung inyong equilibrium concentration, that is the molar solubility as well. And solubility refers to the grams of solute dissolved in 1 liter of a saturated solution. Okay. So, ano relationship ng molar solubility with the solubility? So, they are just related in terms of their mass-mole relationship. So, if you want to get the solubility from the molar solubility, you multiply this by the molar mass. Okay. If you want to solve the molar solubility from gram solubility, then you divide this by the molar mass now. Okay. So yan lang. And here's the general format of solving for problems like this. So suppose you are given the solubility of a compound and you were asked to solve for the KSP. Okay, so first things first, you get the molar solubility if that is expressed in grams per liters first, no? So you get the molar solubility by dividing your solubility by its molar mass. Then once you have your molar solubility, plug it into your ice table that shows the concentration of your species. No? And then later on, you're going to plug it in your K. No? So ito naman, kapag you are given the K, you are asked to solve for the solubility of the compound. So from K, you solve for X, the equilibrium concentrations. Then that also corresponds to your molar solubility. If you want the solubility only, you multiply this by the molar mass. Okay. So yun. So let's try this problem. What is the solubility of silver chloride in grams per liters? No? So we are asked kung ano yung solubility in grams per liter ng AgCl. No? So we show first, no, paano yung dissociation niya into ions. So we can write it as AgCl, solid, because we know silver chloride is a precipitate. So that's AgCl solid, and that will equilibrate into its ions. So ngayon, ang problema, ano yung K? No? What's the KSP for this? Okay. So you have to look at this table para alam natin yung K value. Let's look for silver chloride. Okay, so here's silver chloride. So that's 1.6 times 10 raised to negative 10. Okay, so KSP 1.6 times 10 raised to negative 10. Okay, so since we have an equilibrium equation, as usual, we're going to construct the ice table. So on the left, you have AgCl, Ag plus, and then Cl minus on the right now. As I told you last time, species in solid form are not ought to be written sa ice table. That's why we will leave this column blank. Okay? Bakit iba-blank natin to? Kasi solid yung silver chloride na. So, lalagyan lang natin ng info ay yung nasa right side. According to the problem, do we have initial concentration for Ag? Wala, no? And for Cl, wala ding sinabi. Okay, so kapag walang sinabi about their initial concentration, 0 yan. Okay, so what will be the change? Okay, so as I told you, this can be determined by comparing Q and K, no? Pero, another rule is that kung nasan yung 0, dun pupunta yung reaction. Okay, so on the product side, we have 0 amounts. So that means the change is positive for the products. Positive X and positive X. Okay, so if they have coefficients, you have to include it in your change. No? So for at equilibrium amount, Ag plus is equivalent to X and Cl minus is equivalent to X. Okay, so from this, let's plug it into our KSP expression. KSP for this equation is Ag plus times Cl minus. And we know that at equilibrium, the concentration of Ag and the Cl minus is X. So we plug it here. So we solve for the X value, that is just the square root of KSP. And that's equal to, kakalki ko na. That's equal to 1.26 times 10 raised to negative 5. So this is the X value and it corresponds to the concentration of silver in equilibrium, and at the same time it also corresponds to the concentration of chloride in equilibrium. Okay, so we're not yet done, no? Kasi ang tanong sa atin, the solubility of silver chloride. If you're asked about the solubility of your precipitate, we determine the concentration of metals, no? So, ganun. Metals usually yung hinahanap nating concentration pag ganito yung tanong. Okay? So that means the solubility is equal to the concentration of the metal at equilibrium. Okay, so in our case, that's 1.26 times 10 raised to negative 5 molar. Okay, so ito pala yung tanong. Okay, so ano naman, in grams per liter, paano naman to? Okay. So, for grams per liter, solubility per grams liter, ano kailangan natin gawin dyan? Kailangan lang natin siya i-multiply, i-divide sa kanyang molar mass. Okay, so let's divide this by its molar mass. Kailangan hanapin ko lang molar mass ng silver chloride para mabilis. Okay, so the molar mass of silver chloride is 143 molar mass AgCl, 143.32 grams per mole. Okay. So since we know now the X value, all we have to do is to divide it by the molar mass of the salt, no? Para makuha natin yung solubility ng silver chloride in grams. Okay. So that will be S, no? Solubility in grams per liter. That will just be equal to your X value. That's mole per liter divided by the molar mass, grams per mole. Ay, mali pala yung operation. Hindi magka-cancel out sila. Sorry that we should multiply it by the molar mass pala. 32 grams per mole. And so the moles will cancel out. So the solubility of this salt is 126 times 55 times 1. So the solubility of the salt is 1.805 times 10 raised to negative 3 grams per liter. So if we convert this into decimal, that will be 0.18. Okay, so that will just be 0.0018 grams per liter of solution, no? So ibig sabihin ganyan lang kaliit yung extent ng dissociation ng silver chloride, no? So may 1 liter ka ng solution pero only 0.0018 grams lang yung makukuha mo na ions mo. Okay, so very tiny para maging significant, no? That's why sabi natin these are the sparingly soluble salts, no? Masyadong maliit lang yung kanilang ions at equilibrium. Okay. So ganun lang. So again, if you're asked for the molar solubility, yun na yung X value natin. However, kung gusto mo ng solubility in grams per mole, then you need to solve for you need to multiply your molar solubility by the molar mass lang. Okay, so ganun lang. As long as you know the equilibrium, madali na lang to. Okay. Okay, so in this time, let's talk about the relationship of the KSP and the molar solubility or the value of X. No? So they also call the molar solubility as S, no? Di ba nasanay tayo kapag I stable X, no? But in our case ngayon, that we will call it just the S, no? Okay. So the S is the molar solubility or the value of X. No? If we plug it into our KSP expression for the different salt, we will get the relationships of the K and the S. No? Kumbaga, ito na yung parang format natin dito. Okay. Suppose your cation and your anion is 1-to-1 ratio. To solve for S, that will be the square root of KSP lang. Okay. So again, if ang iyong ionic compound, 1-to-1 lang yung ratio ng iyong ions, to solve for S, that will just be the square root of KSP. Just like yung ginawa natin kanina. Okay, so another example would be the barium sulfate. 1-to-1 lang yung ratio nila. So that means S is equal to the square root of KSP. Ito yung shortcut. Pagkabisado nyo na to, madali na lang na. Okay, so in the next case, you have 2 cation and 1 anion. So if that's the case, 2-to-1 yung ratio nila. Your equilibrium constant will be written as 4s cubed. No? Paano siya naging 4s cubed? Kasi if 2-to-1 yung ratio ng inyong ions, that's KSP equals 2s times s. Pero remember, kapag may coefficient na 2, we also square it. No? Okay. So, nanggaling yan, sir. No? Nanggaling yan sa ice table. Shortcut na lang. Okay. So, kunwari, you have your ion, let's say silver carbonate. If that dissociates into ions, that will be 2 silver plus and carbonate anion. So, at equilibrium, this will be 2x, and then this will just be x. No? If you write it into our k, yung 2x, i-square mo pa siya because again, yung coefficients ginagawa ding exponent kapag nasa k na tayo. So, what is 2s square times s? That will be 4s cubed, no? So, to solve for s, no, for the molar solubility, that will just be the cube root of KSP divided by 4. Okay. So, you can actually skip the ice table process, no? Pag kabisado nyo na to. Okay. So, yun, you can skip the ice table na. Okay, same thing is true for lead fluoride, no? Lead 2 fluoride. So, 2-to-1 yung ratio ng ions natin. So, to solve for S, that will be the cube root of KSP over 4. If ang ratio ng inyong ions ay 3-to-1, no? For example, aluminum hydroxide, 3-to-1 yung ratio niya, isang aluminum, 3 hydroxide mapo-form natin, then our equilibrium expression can be written as 27s raised to 4. Paano yung naging 27s raised to 4? Let me write the dissociation of aluminum hydroxide. Ito yung nasa Kreml S. Yung lasang bakal, aluminum hydroxide yan. Pati magnesium hydroxide. Okay. So if we write the ice table for aluminum hydroxide at equilibrium, we will see that yung concentration ng aluminum will just be X and the concentration of hydroxide will be 3X. 3X because of the coefficient. If you write that into our KSP value, that will be X times 3X and that will be cubed also. Cube yung sa concentration ni OH kasi may coefficient siya na 3. So what's 3 cube? So 3 cube is 27. That's 3 times 3 times 3, di ba? Tapos, we will have x raised to 3 times x. That will be x raised to 4. So to solve for x, that will just be the fourth root of KSP over 27. So yun na. Ito yung mga shortcuts. No? Kahit di ka na mag-ice table, just look at the format of your compound. Then, from that, pwede mo malaman yung x value, yung molar solubility mo. Okay. Kapag 3-to-2 yung ratio ng inyong ions, 3 cation, 2 anion, o kaya 2 anion, 3 cations. No? So, kunwari, ganun yung case. The KSP will be written as 105s raised to 5. And the S value can be obtained as the fifth root of KSP divided by 108. Paano nangyari yon? Saan lumabas yung 108? Sulat natin yung dissociation ng calcium phosphate. Nasa ice table lang lahat ng kasagutan dito. Pero pakita ko sa inyo kung paano nakuha yung mga yon na. So for calcium, that will be 3 calcium 2 plus, and then we will have 2 phosphate ions. At equilibrium, the concentration of calcium will be 3x. For phosphate, that will be 2x. If we write the KSP for this expression, we will get 3x cubed times 2x squared. So what's 3 cubed? Again, that's 27 times x cubed times what is 2 squared? 4 x squared. Okay, so we multiply the numbers. 27 times 4 is 108. Dun lumabas yung 108 dito sa table natin. So 27 times 4 is 108 x raised to 5. X cubed times x squared is x raised to 5. So that's why if you want to solve for x, that will just be the fifth root of KSP divided by 108. So yan. Kahit hindi na kayo mag-ice table, that's okay lang. Just look at the corresponding ratio of your ions. Kapag 1 to 1 yung ratio nila, KSP is just S squared. Or to solve for S, that will be just the square root of KSP. Kapag 1 to 2 yung ratio nila, such as these two examples, KSP is 4S cubed. And to solve for the solubility, the molar solubility, S, that is just the cube root of KSP divided by 4. Kapag 3 to 1 yung ratio, KSP is 27S raised to 4. And to solve for the molar solubility, S, that will be the fourth root of KSP over 27. Kapag 3 to 2 yung ratio nila, that's 108 S raised to 5, or S can be computed as the fifth root of KSP divided by 108. So yun, just look at the formula lang, identify their corresponding ratio, then ito na yung ating format for the KSP. Wala na tayong masyadong iisipin. Okay? So, itong previous problem natin, so tignan natin. So, ano yung format ng ating metals? So, the format of our metal is isang silver, isang chloride. So, that means KSP is x squared or S squared. No? So, we solve for S or the X as the square root of KSP. So, kahit di ka na mag-ice table, as long as you know the the correct ratio of your ions, yun. Nakasagot ka. Okay. So, let's talk about the solubility process naman, no? So, suppose meron kang ions dissolved in your aqueous solution. Kailan mo malalaman kapag magkakaroon ng precipitate, no? Kasi yung formation ng precipitate, hindi yan instant, no? So, gradual yung pag-form ng precipitate. Why, no? Kasi yung ions mo, it has to reach a certain limit, no? Until dun siya mag-precipitate, no? Parang lang yan yung yung mga crystals natin. So, for example, yung sugar crystal. Di naman mabubuo yung sugar crystal agad-agad kapag nilagay niyo yung asukal sa tubig. Okay, so kasi dilute yun. Pero if you increase the amounts of your crystals ng sugar, dun na mag-start yun mag-crystallize, no. So for precipitates, no, ganun din. So initially, kapag mababa yung inyong initial amounts ng inyong compounds, no? Pag mababa yung initial amounts ng compound nyo, yung Q, kaysa sa KSP ng precipitate, wala kang mabubuo na precipitate, no? So kumbaga they are all soluble pa. However, once na lumaki na yung initial amounts mo kaysa sa KSP nila, doon ka na magkakaroon ng precipitate, no? So, same analogy yan as our sugar crystals. Pag konti lang yung sugar na nilagay mo, wala pang crystals yan. However, dagdagan mo ng dagdagan, it will turn into arnibal. Then later on, magiging, magiging candy na yan, no? So, ganun lang din sa precipitate. Pag onti yung ions mo compared to your KSP, then wala ka pang precipitate. However, as you increase the amounts of your ion, you increase the value of Q, your initial amounts, then once na greater na siya than the KSP, doon na mabubuo yung precipitate natin. Okay, so let's apply that concept in this problem. Okay, so suppose we have 2 ml of 0.2 molar sodium hydroxide that is added to 1 liter of 0.1 molar calcium chloride. Will a precipitate form? Okay. So, ang tanong dyan, may precipitate, may mapo-form bang precipitate na? Okay. So, to answer this, anong kailangan natin gawin? Kailangan alamin muna natin kung ano ba yung precipitate na mapo-form natin. So, anong precipitate mapo-form out of those ions? Ano kaya yon? Ang precipitate na ma-form from those ions ay calcium hydroxide, no? Kung naaalala nyo pa yung solubility rules, ang hydroxide, soluble lang yan if meron kang group 1 metals and barium. Okay? So, yun. Pero anything else, hindi na siya soluble. Okay? So, kapag pinaghalo natin to, ideally, may precipitate na mabubuo. Pero, di ba sabi natin kanina dito, there is a limit, no? There is a threshold para mabuo yung precipitates. Okay. So, let's check, no? Kung na-reach ba nila yung threshold para mabuo yung precipitate. Okay. So, let's solve for this. So, sulat muna natin yung formation ng calcium hydroxide, no? So, we have calcium 2+, and we have hydroxide anions. Kailangan natin 2 moles ng hydroxide ions to form the calcium hydroxide precipitate. Okay. So, ayan. Actually, pwede rin naman baliktad na to. No? Baliktarin na lang natin para katulad siya ng sa KSP natin. So, we have calcium hydroxide precipitate, calcium 2 plus AQ, and then we have OH minus AQ. So, sulat natin yan sa ice table natin. Calcium 2 plus, OH minus. So, initially, what is the concentration of calcium in our mixture? Okay. So, ano kaya yung concentration nila in our mixture? Okay. So, ganito lang, no? Ideally kasi, kapag pinag-add mo yung dalawang volume, di ba? Magkakaroon tayo ng dilution. Madidilute yan, di ba? However, since yung ating in-add na volume ay masyadong maliit lang, 2 ml lang yan eh. So, we will assume na ang total volume ng solution ay still 1 liter. Okay. So again, sabi ko sa inyo, ideally, kapag pinaghalo mo yung dalawang volume, madidilute yung ions natin. Pero, since maliit lang yung 2 ml compared to 1 liter, then we are safe to say that the total volume of the solution is 1 liter pa rin. Okay? So, kunin natin yung molarity nito. As is lang yung molarity niya. Hindi na natin gagamitin yung dilution formula. Okay? So, ganun. Same here, same for this one then. Hindi na rin natin gagamitin yung, dito gagamitin natin yung dilution formula. So, for calcium chloride, di na tayo mag-dilution kasi we assume that the volume of the solution is still 1 liter. Pero for sodium hydroxide dito, kailangan natin mag-dilution formula. Kasi from 2 ml, naging 1 liter na yung volume niya. Okay. So, kunin natin yung molarity nito. So for calcium ion, we will have 0.1 molar. How about for hydroxides? Okay. So for sodium hydroxide, dilution formula natin to. So originally, we have 2 ml of 0.2 molar. Tapos ngayon, nasa 1 liter solution na siya. So we use M1 V1 equals M2 V2. Let's solve for the final molarity. That is 0.2 molar times 2 ml divided by the final volume, which is 1 liter or 1,000 ml. So the final molarity of your hydroxide ion is 4 times 10 raised to negative 4. So that's the final molarity of your hydroxides now. Okay, so ganun lang. Again, paano tayo naka-come up with these answers? Okay. So since onti lang yung ating sodium hydroxide na nilagay sa solution, okay, so again, onti lang yung NaO na nilagay natin sa calcium chloride. So we assume that the final volume of the solution is still 1 liter. Okay. Pero kunwari 20 ml na yan, so the final volume will be 1,020 ml or 1.02 liters. No? Doon na magbabago. Pero ito, in our case, we assume that our sodium hydroxide is very tiny compared to your original ions, original amount, no? Original volume of your ions. So for calcium chloride, di na tayo nag-dilution formula kasi we will still get 0.1 molar anyway. However, for sodium hydroxide, dito magdi-dilution na tayo. We started with 2 ml, then later on, naging 1 liter na yung solution natin. So to solve for the final molarity, when you mix sodium hydroxide in this solution, that can be calculated with dilution formula. And we got 4 times 10 raised to negative 4. Okay. So yan. So ngayon, ano gagawin natin? So we are going to plug this into our Q value. No? Okay, so ano yung Q? That's the reaction quotient, diba? So for this, for our precipitates, no, for our ions, Q can be written as the concentration of calcium 2 plus initially, and the hydroxide ion concentration initially. However, kailangan mo siya is square. Squared yan kasi may coefficient tayong 2 kay OH. So, kailangan mo siya is square. So, what's the concentration of calcium initially? That will be 0.1 molar. For hydroxide, that will be 4 times 10 raised to negative 4 squared. So, let's solve for Q. Q is 1.6 times 10 raised to negative 8. Ano gagawin natin? We are going to compare Q with the K. So, ano yung K ng calcium hydroxide? So, hanapin natin dito sa table kanina. Calcium hydroxide, ito siya. So, K is 8 times 10 raised to negative 6. Okay. So, let's compare Q and K. So, with respect to their values, we can say that Q is less than K. So, will a precipitate form or walang mabubuo? So, the answer is wala pang precipitate na mabubuo. No? Bakit? Kasi Q is less than K. No? According to this, sabi natin, kapag masyadong onti pa yung amounts ng ions natin, no precipitate will be formed because we have an unsaturated solution. That means we have to increase the amounts of sodium hydroxide pa or the calcium chloride. Kailangan mo pa siya dagdagan so that ma-reach natin yung threshold, no? And the precipitate will later on form. Itong mixture, sige, try natin. So, let's try this, no? Suppose you have solutions with barium ions and chloride ions, and yung concentration nila ay 0.02. Okay. So, what is the concentration of silver that is required to precipitate only silver bromide, no? So, sabi diyan may muted ako. So, okay, so anyway. So, yeah, meron tayong bromide and meron tayong chloride sa ating mixture, 'di ba? Ang gusto natin ay yung silver bromide lang yung magpe-precipitate instead of the entire mixtures, no? Kasi dalawa yung precipitate na pwede mabuo natin diyan. Pwedeng silver bromide, pwede ring silver chloride. Pero sa case na to, ang challenge is gusto natin silver bromide lang yung kailangan ma-precipitate. Okay? So, paano yan, no? So, ang kailangan lang natin gawin dito is ganito. We just get the concentration of silver required to precipitate bromide and chloride. So, alamin natin yung concentration ng silver that is needed to precipitate bromide and chloride. How? So, you write the KSP for the two muna. So, for silver bromide, that will be Ag plus and Br minus. So if we write the KSP for this, that will just be the concentration of Ag plus and Br minus. So from the KSP, kunin natin yung concentration ng silver needed to precipitate silver bromide. No? So alamin natin. So paano yon? That is just Ag plus equals KSP over the concentration of Br minus. The KSP for silver bromide is 7.7 times 10 raised to negative 13. Okay. So just look at the table. Naka-open na siya sa akin. So yan. So according to the table, the KSP of AgBr is 7.7 times 10 raised to negative 3. So what will be the concentration of silver needed to precipitate this? So that will be Ag plus equals 7.7 times 10 raised to negative 13 divided by the concentration of bromide. So according to the problem, it is already 0.02 molar. So the concentration of silver needed, no, to precipitate the silver bromide is 7.7 times 10 raised to negative 13. 385 times 10 raised to negative 11. Okay. However, ang problem natin dito, alamin din natin, no, kung kailan mabubuo yung silver chloride naman. So, alamin natin anong concentration mag-start mabuo yung silver bromide, no. So, same approach pa rin. We write the dissociation of silver chloride into ions. So, KSP is given as, tignan ko lang sa table. So, that is 1.6 times 10 raised to negative 10. So, we write the KSP of this. That's concentration of silver, concentration of chloride. So, to get the concentration of silver, that is just KSP divided by the concentration of chloride. Okay. So that will be 1.6 times 10 raised to negative 10 divided by 0.02, sabi sa problem. So that will be 8 times 10 raised to negative 9 molar. Okay. So dito natin malalaman kung ano yung allowed concentration ng silver para ang ma-precipitate lang natin ay yung silver bromide. Hindi madadama yung silver chloride. How? So ganito lang. Kailangan yung concentration ng silver mo ay greater than this, pero less than this, no? Okay. So, sabi natin, di ba kanina, Q must be greater than the K, no? To precipitate our ions. So, that means dapat ang concentration ng silver ay greater than the equilibrium concentration of silver to precipitate the ion, no? Silver bromide. So, kailangan greater than this, no? However, it should not exceed this value. Bakit? Kapag nag-exceed to sa value na to, chloride will start precipitating as well. Okay? So, again, when you have mixture of two ions, para malaman nyo kung kailan pwede mag-precipitate yung isang ion lang, you get for the equilibrium concentration of the metal. Okay? Yun for the two products na pwede mabuo, no? So, in our case, it's silver bromide and silver chloride. Alamin mo yung equilibrium concentration ng metals natin. Okay? Then, from this, alamin mo kung ano yung mga limit, no? O, ano yung limit para hindi mabuo yung isa pa, yung silver chloride in our case. So, sabi natin, kailangan ang concentration ng silver para mabuo yung AgBr ay ito. Okay? So, ito yung kailangan niyang concentration, pataas. Pero it should be less than this, no? Yung 8 times 10 raised to negative 9. Bakit? Kasi kapag lumagpas siya dito, yung silver chloride, mabubuo din siya, no? Hahalo siya sa precipitate, no? Okay? So, ang tawag dito sa process na to ay fractional precipitation because we are precipitating ions one at a time, no? So, bromide muna before the chloride. In our case, gusto natin yung bromide lang. So, the concentration of Ag required to precipitate bromides only is greater than this but less than this na. Greater than this para mabuo yung precipitate na AgBr. But again, less than this kasi kapag lumagpas ka dito, silver chloride will start forming na. Okay, so yun lang yung approach dito sa fractional precipitation. You get the equilibrium concentration of the metals needed to start the precipitation of the two precipitates. Okay. Then alamin mo sino muna yung mabubuo una, then sino yung susunod, no? Okay. So kung gusto mo yung una lang yung mabuo, then you should not exceed the concentration required to precipitate the other. So kailangan hindi ka lumagpas dito para hindi siya mabuo. Kailangan dito lang pataas, but less than this. Okay, so in words, that will be 3.85 times 10 raised to negative 11. That should be greater than x and less than 8 times 10 raised to negative 9 molar. So that means the concentration of silver should be greater than this but less than this. Greater than this para mabuo yung AgBr. Less than this para hindi mabuo yung silver chloride. Okay. I think isang ganito lang ata yung nasa quiz. Okay. So, ganyan lang yung format niya. Okay. So, punta na tayo sa last part ng discussion natin. Mabilis lang talaga tayo today, no? So, let's talk about the common ion effect and its effects sa solubility, no? So, sa lecture nyo, ano yung sabi niya sa common ion effect? So, according to your lecture, common ion effect is an application of Le Chatelier principle which states that if you have common ions in your solution already, it will shift the equilibrium to the left. And that results your salt to be less soluble. Okay? So, yan, application yan ng Le Chatelier principle. So, ibig sabihin, if you have ions already in your solution that is common to your salt or common to your precipitate, the precipitate will now be less soluble. Okay? Kasi shift to the left yung ating equilibrium. Okay? So, let's try this problem. What is the molar solubility of silver bromide in pure water and in 0.001 molar sodium bromide? Okay, alamin natin yung solubility niya in pure water and then let's compare it with 0.001 molar sodium bromide solution. So, using Le Chatelier principle, saan kaya siya mas magiging soluble? Mas magiging soluble yan sa pure water. Bakit? Kasi for sodium bromide, meron tayong common ion effect dito. Ano yung common ion natin? Yung Br. May Br na kasi dito sa solution na to. So as a result, shift to the left yung solubility ng AgBr natin. So mas lalong bababa yung kanyang solubility. Pero i-apply natin yung concept sa calculation para makita natin na totoo ba talaga yung idea ng common ion effect. Okay. So let's write this dissociation of silver bromide. So that will be AgBr in equilibrium with Ag plus and Br minus. So AgBr, that will be in equilibrium with Ag plus and Br minus. So in water, water lang, 0 yung concentration ng dalawang ions natin. So at equilibrium, that will be just X now. So again, to solve for X or the molar solubility, that is just the square root of KSP. Yun yung nasa table nung una, di ba? Ano ba yung KSP uli ng AgBr? Okay, so for AgBr, KSP is 7.7 times 10 raised to negative 13. So what will be the molar solubility of AgBr in water only? So that is 7.7 times 10 raised to negative 13. So that will be 8.77 times 10 raised to negative 7 molar. So in pure water, the solubility is, ayan, 8.77 times 10 raised to negative 7 molar. Okay. So mababa pa rin, no? Pero mas bababa yan kapag may NABR because of the common ion effect. Okay. So pakita natin using calculation na mas bababa talaga siya dito. Okay. So let's try naman letter B. So for letter B, we have common ions, sodium bromide in our case. So yung silver, wala tayo niyan. Pero yung bromide ion, ano na yung meron tayo? Initially, meron na tayong 0.001 molar niya. Meron na tayong amounts ng NABR. Okay? Ibig sabihin, madadagdagan pa yan. So, alamin natin yung change. So, still sa product side, 0 yon. So, this will be positive X. This will be positive X. So, this will be X, 0.001 plus X. So, to write the KSP, that will be equal to the concentration of Ag plus Br minus. So, in our case, letter B, that can be written as X times 0.001 plus X. Di ba kanina X lang yan? Ngayon, meron ng 0.001. Saan to galing? Sa initial amount ng NABR. Kasi may common ion effect tayo. So from this, we can solve for the value of X. Okay? So distribute lang natin yung terms. Okay? So can we use the square root of tsaka dito? Pwede. So we can use the square root of tsaka. No? Determine mo muna if our wala pala tayong initial amount ng AgBr. So we cannot use the square root of tsaka kasi wala tayong initial amounts nito. So no choice, quadratic equation tayo today. So 0.001x plus x squared. Okay, so ito yung magiging quadratic equation natin. So ito yan. Switch ko lang yung x squared pati yung x. Okay, x squared lang pala. Hopefully by now, mabilis na tayo mag-quadratic, ha? Ayan. Okay, so this will be our quadratic equation. So, shift solve tayo. O kaya, yung calculator technique. Equation. That will be 1.001 KSP kalimutan ko negative sign. Okay, so we have 2x values. Of course, dalawa dapat yan. We have 7.7 times 10 raised to negative 10, and the other is negative 1 times 10 raised to negative 3. So, di ko gagamitin yung negative 1 times 10 raised to negative 3. Kasi negative root yun eh. So, yan. So, this will be the molar solubility of AgBr in a solution of 0.001 molar NaBr. So, ano nangyari? Sa solution ng water, ang solubility ng AgBr ay ito, times 10 raised to negative 7. Pero, sa solution ng NaBr, ang solubility ng salt natin ay times 10 raised to negative 10. So, the solubility was decreased by 1,000. No? 1,000 times siyang mas naging less soluble because of the presence of the common ions. Okay. So, yun yung reason bakit mas soluble yung AgBr sa water lang kaysa sa NaBr. Okay? So, yun. What if, kunwari, may, meron kang, let's say, KNO3. What will be the effect of KNO3 sa AgBr? So, ito yung tinatawag nating salt effect, electrolyte effect, or diverse ion effect. Ito sa lecture to, chapter 4. Sabi doon, sa lecture, kapag diverse ions, ibig sabihin ions that are not common to your equation, yun ay magpapataas lalo ng magpapataas siya lalo ng solubility ng salt mo. Okay? Kasi you have to compute for the activities and the activity coefficient of the ions na, no? Okay, so yun lang. So again, kapag common ion effect, it will decrease the concentration of the it will decrease the solubility of your precipitates pala. Okay, so it will decrease the concentration of your precipitates kapag common ion. Pero according sa lecture nyo, kapag diverse ion, it will increase the solubility. Okay. So sa lecture na bahala dyan, hopefully natapos nyo na. Okay. So actually may materials na ako about that, no. Sa activities and activity coefficient nasa na siya. Nasa canvas na, no, sa lecture. Pwede i-download nyo rin 'yan. Okay? So yun lang. Ito yung common ion effect and the solubility. Mathematically, we just saw that when we have common ions, bababa yung solubility niya lalo. And according sa lecture, kapag may diverse ions, tataas yung solubility niyan. Okay? So you have to compute for the ionic strength, activity coefficient, the activity, di ba? So on and so forth. Okay. So ito pa yung ibang mga bagay sa atin. No? So ito pa yung mga ibang rules that could affect the solubility of our salts. No? So sabi nga natin, in the presence of the common ion, ang solubility ng ating salt ay made-decrease, no? So, yan. So, mas lalong bababa yung solubility ng ating salt kapag may common ion effect. No? Kasi na-affected yung ice table eh. Okay. Kapag meron naman tayong insoluble bases, mas magiging soluble daw sila in acidic solution. Okay? Mas magiging soluble ang bases kapag nasa acidic solution. And the counterpart is true for the acid. Yung insoluble acid, they will be more soluble in basic solution. Okay? So bakit? Ang sagot dyan ay common ion effect din. Okay? So try natin sagutan tong problem na to. This is our last problem for today. Okay, so consider magnesium hydroxide in acidic and basic solution. So, saan siya magiging soluble? Sa acidic or sa basic solution? Okay? So, para masagot natin yon, kasi may isang item ata na ganito sa quiz nyo. So you are given a salt, then tatanungin, saan siya mas soluble, acidic o basic? So to answer that, ganito lang. You identify the pH of the solution. Okay? So, or the pOH. No? Okay? So, alamin mo kung ano yung pH ng solution mo. So, since this is a basic, insoluble base to, so it will produce hydroxide ions. So, pwede natin makuha yung pOH, then later yung pH niya. Okay? So, pakita ko lang yung reaction dito. So, wala naman sa ating sinabi initially. Okay? So, this will be plus x, this will be plus 2x. So, x, 2x. So, KSP for this salt is 4x cubed or 4s cubed. Okay. Bakit 4s cubed? Kasi, ayan. So, you have x, then you have 2x. Is-square mo pa to kasi may coefficient na to doon. So, we get 4x cubed. Kaya nga sabi ko sa inyo, kahit di ka na mag-ice table, basta kabisado mo yung formats, no? For different types of ionic compounds. Yun. Mabilis mo na siya makukuha. Okay, so let's solve for the value of x. So x will be just the cube root of KSP divided by 4. So cube root ng KSP divided by 4. That's 144 times 10 raised to negative 4. Okay. Then, paano natin kukunin yung pH dito? Alamin mo muna yung OH concentration. The concentration of OH at equilibrium is 2x, sabi dyan. So, ito times 2 mo pa yan. Okay. So, times 2 natin yan. We will get 2.88 times 10 raised to negative 4 molar. pOH is negative log concentration ng OH. So, pOH is equal to 3.54. The pH of the solution is 10.46. So, the pH of the solution, when we dissociate magnesium hydroxide, ito yung nasa Kreml S. Okay. The pH is 10.46. Okay. So, ang tanong dito sa atin, saan siya mas soluble? Sa acidic or sa basic solution? Okay. Ano yung sabi kanina? Pag may bases tayo na precipitate, mas soluble daw siya sa acidic solution. It will dissolve in acidic solution. Bakit? Bakit kaya? Ang sagot ay nasa equation, the Chattier principle. Okay. So what will happen kapag nasa acidic solution tayo? What happens in acidic solution is that yung OH natin nababawasan. Bakit? It reacts with H plus to form water. So that in acidic solution, yung concentration ng OH ay bababa. Since binabaan mo yung concentration ng product, ano sabi sa Le Chattier principle? When you decrease the concentration of your products, the equilibrium will be shifted to the right. Diba? So that magnesium hydroxide will be more soluble in acidic solutions. Bakit? Acids react with OH to produce water. So yun, it reacts with H plus to produce water. So ibig sabihin, nababawasan tong OH. As a result, the salt will provide more ions. Ibig sabihin nun, mas magiging soluble siya. Okay. That's why yung Kreml S, pag tinunaw mo yan sa tubig, buo-buo pa yan, pero pag yan ay nasa sikmura natin, tunaw yan lahat, no? Okay, because our acid in the body reacts with the hydroxides to produce water. So, lahat ng magnesium hydroxide matutunaw, okay, in the presence of the acid. Kasi binawasan mo yung amounts ng products mo. What if ito ay nilagay natin sa base, no? Kunwari, nilagay natin yan sa sodium hydroxide solution. Ano mangyayari? sa presence ng sodium hydroxide, may additional OH ka. So, ito ay common ion effect. It will shift the equilibrium to the left naman. Okay? So, yun. So, generally, itong ginagawa natin, this is just the application of Le Chatelier principle. Okay, so yun. Kapag ikaw ay may base and siya ay nilagay mo sa basic solution, the precipitate will be less soluble because of common ion effect. But if you place your precipitate in acidic solution, the equilibrium will be shifted to the right. No? Kasi mababawasan yung OH mo sa solution because that reacts with H plus to produce water. Okay. So that means this solution, this precipitate, no, will be more soluble. The precipitate will be more soluble if the pH is less than 10.46 and less soluble if the pH is greater than 10.46. No? Okay, so kapag acidic yan, ibig sabihin less than this, dun siya mas magiging soluble. Pero, pag basic yan lalo, mas mataas pa kaysa dito, dun siya magiging less soluble because of the common ion effect. No? Okay, so yun lang. That's all for the solubility equilibrium na. So again, to summarize, yung quiz dito pala madali lang naman. So yan na naman ako sa madali lang. Bakit? Kasi sabi ko nga, as long as you know this table, basta kabisado mo tong table na to, kaya mo masagutan lahat, no? Ayan. So, yan. So, be familiar na lang para hindi na kayo mag-ice table. Although, still, I prefer ice table. No? So, yan. So, to summarize, so we have the solubility equilibria. This describes the equilibrium expression for our precipitates now. And we call it the KSP or the solubility product na KSP. Okay, ito yung KSP values natin, solubility products of different precipitates. Okay, so we have two terms here that describes the solubility of our precipitates now. Molar solubility, this is the X value sa ice table. Ito yung X that refers to the amounts in terms of mole of your precipitate that dissolves in 1 liter solution. Kung gusto mo yung molar solubility mo, gawin mong gram solubility. You just multiply it by the molar mass. Okay. So, yan, sinagutan natin yung kanina. Okay. So, basically, to solve for the solubility of AgCl, you just get X equals square root of KSP. Okay. So, according to this table, yun yung relationship nila. To solve for the molar solubility, that is just the square root of KSP. Then once you are able to solve for X, yun yung molar solubility. Okay. Then to convert that into gram solubility, I call it gram solubility kasi naka-grams. You just multiply X by your molar mass. Okay. Also, yung precipitates natin, di yan agad-agad mafo-form. So, kailangan mo gawin, you have to compute for the Q, the reaction quotient, and compare it with your K. No? If your reaction quotient is less than the K, that means wala pa ikaw precipitate. No? Pero if yung Q mo greater than K na, dun na tayo mag-start magkaroon ng precipitate. Okay? So we use that concept dito. Inalam natin kung may precipitate ba tayo mabubuo dito. And the answer is, wala tayong precipitate na mabubuo. Kasi we just solved that Q is less than the K value. Okay. So, ganun lang. Again, don't forget, no? Kapag onti lang yung ml ng inyong ions, yung greater volume yung masusunod na final volume. Pero kunwari ito ay 20 ml o kaya 200 ml, doon ka nagagamit ng dilution formula. So, every time you add 2 volumes, you must use dilution formula unless masyadong maliit yung isa compared to the other. Such as in our case. Yung 2 ml, ilang droplets lang yan eh. So ito naman, ito yung concept ng fractional precipitation. So, sabi natin kanina dito, when doing fractional precipitation, kunwari yung isa lang gusto ma-precipitate compared to the other, you get for the amounts of the metal required para mag-precipitate yung mga yan. So kunin mo yung amount ng metal that is required to precipitate bromide, and kay chloride ganun din using the KSP expressions for the two. Then, from those info, i-compare mo, sino yung mauunang ma-precipitate, no? Yung mauunang ma-precipitate ay yung may lowest metal concentration required, no? Para mag-precipitate yan. In our case, kanina, yun yung AgBr. Di ba? Mas mababa yung concentration ng Ag kaysa sa nasa AgCl. So, unang ma-precipitate talaga si Br compared to Cl. And again, common ion effects, sabi lang natin dito, this is an application of Le Chatelier principle. If you have common ions, it will shift the equilibrium to the left, no? So if you are asked, saan siya masoluble? Sa water or dito? So ang sagot dyan always ay sa water. Bakit? Kasi in the presence of diverse ions, shifted to the left yung ating equilibrium. Okay? However, sabi sa lecture nyo, in the presence of diverse ion, for example, potassium nitrate, in the presence of diverse ions, the equilibrium will be shifted to the right, no? Mas magiging soluble siya. Okay? So again, kapag common ions, such as NABR, ito ay common ion effect. And pwede natin i-apply si Le Chatelier principle. Okay? Pero kapag diverse ion yan, sabi sa lecture nyo, ito yung diverse ion effect. And may kinalaman na yung ionic activities dito. More soluble. Di ko lang maalala kung may ganitong item ako na nilagay sa quiz. So, you're given water, common ion, diverse ion. Pipiliin mo kung saan siya mas soluble. Obviously, sa diverse ion. Pero kunwari wala sa option yung diverse ion, edi sa water lang yung pipiliin nyo. Okay? So, ganun lang. Okay? So, again, pH and solubility. So, kapag may base ka na precipitate, it will be more soluble in acid. If may acid ka na precipitate, it will be more soluble in basic solution. Okay. Kasi sabi natin, kapag may basic compound ka and nasa base yan, it will shift the equilibrium to the left because of the presence of OH na. May OH na kasi kaya common ion effect yan. However, in the presence of acids, it will shift the equilibrium to the right, no? Bakit? Kasi yung OH mo, mababawasan yan. Puro araw tayo. Okay? So, yan. So, kapag nabawasan yung ating OH, shift to the right yung ating equilibrium. Ibig sabihin, mas magiging soluble siya. So, for bases na precipitate, more soluble sila sa acid. Kasi nababawasan yung OH. Applying Le Chatelier principle, shift to the right yan. No? Okay? So, that will be all. No? And tapos na tayo for the topics sa midterm. So, yan. So, we are done with the midterm topics na. Ito na lang onting reminders. Okay, so punta na lang tayo sa reminders today. We're almost done. So, reminders natin, una, punta tayo sa calendar nyo. Although wala pa naman ako nilalagay masyado dito. Okay, so deadline ng quiz for part 1 nyo is Wednesday. That is just about acid solubility, no? Yung square root of tsaka, yun, dyan yan. Okay, and then yung characteristics ng acid bases, ano yung definition ng acid, ano definition ng base. Okay, so dito lahat yan sa part 1. But for part 2 naman, that will be due on Saturday. Ito na yung buffer, itong solubility effect, no? And the common ion effect, no? So, yan. So, yan. So, by Wednesday, may quiz kayo na due. And then by Saturday, may quiz kayong due ulit, no? Also, ang ginawa ko pala dito sa quiz nyo, for part 1, that is 45 minutes, 2 attempts. Okay? So, 2 attempts yan. So, galingan nyo na lang. Multiple choice tayo. Okay? So, hindi na kayo mag-worry about the decimal places. Okay, so yan, 45 minutes, 2 attempts. The record to be kept will be the highest score. Okay? And for part 2, since ito ay solubility, ibig sabihin, puro calculation talaga dito. Ginawa ko na lang siyang 60 minutes, 1 oras, kada attempt. Okay? So, hopefully enough yung enough yung 2 attempts, no? Para dito sa part 2. May question tayo. Ilang attempts po ang exam? So, since ang exam natin ay departmentals, yung rules ng departmental exam yung masusunod, no? So, maybe around 1.5 hour yon, but good for 1 attempt lang. Okay? So, yun lang yung catch doon. Siyempre, longer hours siya kasi 50 items yun eh. So, maybe around 1.5 hour yung exam ninyo. Pero that is only good for 1 attempt. Dito pala kayo magte-take ng exam. So, makikita nyo, di ba sa canvas nyo, departmental exam for Anachem. Dito lahat magte-take ng deptals. Ayan. So, wala pa kami nilalagay dito, pero, yan. Dito lalabas yung exam nyo. Okay? So, yan. Lahat yan ng students dito. Yan, nandyan yan sa people. Okay? So anyway, so ganun lang. 1 attempt lang yung exam. No? So, kailangan galingan nyo talaga. No? And don't worry, madali lang naman. So ano pala yung coverage ng ano yung coverage ng midterm exam? Okay, the coverage of the midterm exam for the laboratory, chapter 1 to 4 and including yung chapter 0 natin, yung orientation. Ano ba yung diniscuss natin dito? Ang diniscuss natin dito ay yung tools of trade, no? Ano yung mga tools na ginagamit sa Anachem. Ayan, so terms lang naman yung nandito. Okay? So puro terms lang, kaya ayan, reviewin nyo na lang din. Okay? So about calibration, etc. etc. So ayan. So read nyo na lang yung overview. Okay? Kasi may mga questions na included yan. Especially yung mga terms about sino yung ginagamit to transfer liquids, pwedeng pipette, no? Pwedeng burette, no? So, ganun. So, lang, puro words lang yun, kaya hindi naman masyadong mahirap. Then, for the others, ito na yung may mga calculation na. So, good luck. Okay? For gravimetric analysis, di ba, ang ginawa ko sa inyo, may mixture ng may mixture ng dalawang salt. Sa hanapin mo yung kanilang percentages. Meron pa rin atang ganun dito sa midterm exam nyo na ganun. Okay. So, baka may lumabas. So, that means dapat alam nyo na kung paano siya sagutan. You create 2 equations. Gawa kayo ng dalawang equation para masolve yung value ng x and y and then later on yung percent nila. Yung stats, madali lang yan, no? Basta alam nyo yung alam niyo yung measure for accuracy and precision. So, ano nga ba yung measure for accuracy? The measure for accuracy is the percent error. Nabigay ko na yung percent error equation dati. So, panoorin nyo na lang uli sa chapter 2. And the measure for accuracy, the measure for precision naman is the standard deviation. Kapag mababa yung standard deviation, yun ay precise. Pag mababa yung percent error, yun ay accurate. No? So, yan. Ako na rin sinabi, 5% error lang yung accepted. Tapos, ang percent error mo ay 4%. Ibig sabihin, accurate yung measurement mo. So anyway, mga nakwento ko na rin naman dito sa video natin dito. Okay? So, balikan nyo na lang. So yun lang, basta alam nyo how to solve for standard deviation. Kung alam nyo na using calculator, that will be better. And again, measure for accuracy, percent error. Measure for precision is the standard deviation. The lower the standard deviation, the more precise. No? The lower the percent error, the more accurate. Okay. So yun lang. Ano pa? And solutions, alam nyo na yan, molarity, percent volume, density to molarity, vice versa. So yun, paki-recall na lang sila. Then itong chapter 3, ayun, about precipitation and combustion lang. And then lastly, we have the acid-base equilibrium and the solubility. Okay, so ito yung ating mga materials na. So ayan, so for chapter 4 sa lecture na upload ko na kagabi. Inuna ko to kasi kukwis na kasi sila agad dito. Hindi na kami mag-meet this week eh. So kung gusto niyo rin tignan yan, yung mga gamma-gamma, di ba UKEL? So yan, pwede basahin nyo na lang din yan. And then, for the lab, hindi ko pa natatapos yung sa chapter 4 nyo. Okay, so wait lang kayo. Okay. So yan. And also, pagdating, before the midterms, no, maybe around weekends, mag-open ako ng mock exam. So mag-open ako ng non-graded exam. Non-graded yon kasi try lang. So, pwede nyo siya i-take, pwedeng hindi. Kayo bahala, no? So, I will open that around weekends, no? Pwede yun na rin gamitin nyo as reviewer. Okay. And magdadagdag ako ng mga materials nga dito. So, check nyo na lang to uli mga weekends or kapag nag-announce ako. Okay? And also, may in-update pala ako dito yung mga errors ko, mga typo-typo. Nilagay ko na rin dito. Okay? So, naayos ko na. So, thank you dun sa mga nakakapansin ng errors. Kasi, to be honest with you, ginagawa ko siya ng gabi. Kaya, puyat-puyat din ako. No? So, yung mga errors dito, na-correct ko na. Yung mga equation, mga nakalimutan ko na 2, kaya hindi ko na-distribute. No? So, just always message me kapag may napansin kayong error para makorek natin. Okay, so for gravimetry, may dinagdag pala ako dito sa last part. Although nakorek ko na yung iba dyan. Diba sa last part, ang nakalagay lang dito initially, kailangan 1 decimal place, diba? Pagdating dito sa reduced moles. So, dapat 1 decimal place. Yun yung sabi ko last time. Pero I forgot na meron nga palang factor 4.25 na decimal. Okay, so, ang naalala ko lang kasi that time nung dinidiscuss ko yun, yung 0.3 pati yung 0.5. Diba pag 0.3 times 3 lahat, no? Para maging, integer. Tapos kapag 0.5 times 2 lahat para maging integer. Pero, there are cases na 0.25 yung nakalagay. So, kung narin nakuha nyo, 0.25 na reduced moles, huwag nyo gagawin siyang 0.3. Kasi yung 0.25, pwede yan maging integer when you multiply it by 4. Okay? So, ganun. That's the reason why dalawa yung nilagay kong sagot dun sa isang item sa quiz 3. Okay, yung sa quiz 3, i-upload ko rin yung answers na na-busy lang talaga ako sa school din. Okay. Okay. So, nag-aaral din ako. Yes. No? Okay, so yan. Kaya hindi ko pa rin siya tapos. Pero don't worry, papakita ko lahat ng calculations doon. Yun yung reason bakit dalawa yung answer sa isang item doon. Yung sa isang combustion analysis. Merong pakita ko na nga. Ito, sinasabi ko na to lahat para aware kayo sa mga lalabas sa exam. Ito yan. Naka-release na naman yung answers eh. Okay. So yan. Ito. So sa last item, dalawa yung correct answer. Okay. So dalawa yung possible correct answer. Pwedeng ito. Pwedeng ito. Pero ano yung mas acceptable? Itong una, itong C4H9. Kasi ang decimal doon sa reduced mole ay 0.25, no? However, mali ko na rin naman, kaya kinorek ko na rin yung mga nagsagot na itong C3H7. Okay. So, pero yun nga, however, sabi ko nga sa inyo, yung 0.25, pwede siya maging integer by multiplying the equation by 4. Okay? So, you can actually retry this problem. Makikita nyo na yung reduced mole ay 0.25. No? So, if that's the case, 0.25 yung reduced moles mo, then ita times 4 mo lahat ng reduced moles para maging integer yung subscripts. Okay. Ang ginawa kasi natin last time yung 0.25 dito, ginawang 0.3 kaya naging ganito, 'di ba? Okay. So anyway, papakita ko naman yung solution dito. So again, ongoing pa rin yung solutions dito. Ang dami kasi nitong calculation na 'to. So ongoing yung pag-type ko ng answers dito. So wait nyo na lang yung pag-type yung solutions and then yung worksheet for laboratory para marami kayong reviewer for the exam. And also, mag-open nga ako ng mock exam. So, yun lang mga pointers ko ha. So, for each chapter, may paalala na naman ako. So, hopefully, makatulong yung mga yun para, pumasa kayo sa midterm exam. So, again, departmentals to. Ang makikita nyo sa exam ay halo-halong question from different instructor. So, yun. May lalabas from ibang professor, may lalabas from sa akin, no? Pero in the end, as long as you know the concept, you can answer the problems, no? And yun. And lucky for you, sandamukal yung mga materials natin, no? So other than the worksheets, upload ko pa yung answer key ng quizzes, no? Yun dun sa, sa quiz 3 pati quiz 4. Yun yung mga pwede ko i-upload yung answers. Kasi yung stats pati part 1, masyadong madali na yan. Kaya nyo na yun eh. Pero for the equilibrium calculations and the gravimetry, papakita ko yung solution. Okay? And other than that, ito yung mga worksheets natin. So hopefully, ako I'm rooting for all of you, no? Kayo mga hawak ko. Sana kayo yung mga nasa mga top 10 or let's say top 20 sa midterm exam. Hopefully, ayun, mataas naman expectation ko sa inyo kasi magagaling naman kayo, no? So, yan. So, yan. Good luck and maybe I will see you again by kailan ko ba kayo uli makikita? So, this Thursday, wala na tayong klase. Pahinga na tayo. So, you can focus on your review. And by weekends, maglalagay na ako ng mga materials. Additional material, mag-open ako ng mock exam. Okay? Around Saturday or Sunday, mock exam, mag-open ako. That is not graded. Pwedeng hindi kayo mag-participate, okay lang. And then for the last part, for the next week, ito na yung exams nyo sa buong FEU. So 15 to 20 yon. So good luck. Then 22 to 27, this will be, ito ay magiging, consultation week. So basically, ang gagawin lang natin dito is, magko-consult tayo, ano yung midterm grade nyo, paano na-compute yon and paano nyo may improve yung grades nyo. Okay, so ito na yung moment of truth for the midterm. Okay. Then, Semana Santa. So most likely, dito sa, fourth week ng March, lang tayo, isang klase lang tayo dito kasi yung isa that will be dedicated for the consultation. Then yung isang meeting magdi-discussion. And then we will have the Semana Santa. Okay, Holy Week. Okay, so hanggang dito yun. Then, back to normal ulit tayo April 5. No? So, medyo matagal-tagal pa bago maging normal yung ating schedule. Okay? So, yun. Hopefully, yun, I'm rooting for you. So, sana wag kayong ma-pressure, no? Kasi you have all the materials naman. Actually, ginagamit nga rin ng ibang prof yung materials ko, no? Yung mga worksheets ko, ginagamit din nila. Okay. Kaya yun. So, hopefully makatulong yung mga yun para mataas scores niya. Okay? So, I'll see you again sometime mga next week, no? Makikita niyo ako ulit. So, yan. Good luck with your review and all the best always, no? Okay? So, yun lang. Dami kong sinabi, no? Okay, so yun lang. Yung copy ng class recording will be uploaded on YouTube for reference. No? Okay? So, good luck and